Watts measure how much electrical energy is actually being used or converted into something else, like light or heat or motion. Think of watts like measuring how much work is actually getting done. Now let's get back to our water analogy. Imagine you have a water wheel, like the kind they used to have at old mills. The water flows over the wheel and makes it spin, and that spinning motion can be used to grind grain or power other machines. The voltage is like how hard the water is pushing. The amps are like how much water is flowing, but the watts would be like measuring how much actual work the water wheel is doing. How fast is it spinning? How much grain is it grinding? That's the watts. In electricity, watts tells you how much power a device is actually using. A small LED light bulb might use 10 watts. That means it's converting 10 watts of electrical energy into light energy every second. A hairdryer might use 1,500 watts. That's a lot more electrical energy being converted into heat and air movement. Your microwave might use 1,000 watts or more, converting electrical energy into those invisible wiggling fingers that make your food hot. Here's a really important thing to understand about the relationship between volts, amps, and watts. They're all connected by a simple math equation. Volts times amps equals watts, or as math people like to write it, V times A equals W. This means if you know any two of these numbers, you can figure out the third one. Let's try an example. Say you have a light bulb that uses 60 watts and you know your house voltage is 120 volts. How many amps is that light bulb using? Well, if volts times amps equals watts, then amps equals watts divided by volts. So 60 watts divided by 120 volts equals 0.5 amps. That light bulb is using half an amp of current. Or let's say you have a device that uses 2 amps of current at 120 volts. How many watts is it using? 120 volts times 2 amps equals 240 watts. You see how that works? This relationship helps explain why some things work the way they do. Remember how your phone charger takes 120 volts from your wall and turns it into 5 volts from your phone? Well, your phone might need 10 watts of power to charge. At 120 volts, that would only need about 0.08 amps. But at 5 volts, it needs 2 amps. Same amount of power, just delivered differently. This is also why high voltage power lines are used to transport electricity over long distances. It's more efficient to send electricity at really high voltage and low amps than it is to send it at low voltage and high amps. Remember, the wires themselves have resistance, kind of like friction. When electrons flow through a wire, some of their energy gets converted to heat because of the resistance. And high watts means a lot of energy is being converted, which often means a lot of heat is being generated. But in normal, everyday situations with properly working electrical devices, you don't need to worry about any of this. The engineers who designed your phone charger and your microwave and your light bulbs have already figured out all the safe combinations of volts, amps, and watts. They've built in safety features and designed everything to work together properly. You might have noticed that many electrical devices have labels on them that list their voltage, amperage, and wattage